All right. So today we are going to talk about, as I have already mentioned this in the syllabus, that I'm going to talk about majorly set theory and basics of real number and some of the important facts that everyone should know who wants to get into economics field. Uh, Feel free to ask any question if you feel that you did not understand the concept or you have any doubt, you can ask me, interrupt me, okay? But try to make your questions legit. That way everyone would benefit from that. So let's start with set theory, and I'll quickly finish real number. I'm sure you all have some idea of real number system, so I think it's not a big deal. But set theory is a topic for many of you who haven't studied mathematics or didn't have mathematics background. For many of you, it's a new concept. Okay, so yeah, what is set? Set is basically collection of any items or objects. So what is the convention to denote a set? So conventionally, we follow capital English alphabet. So for example, A, B, C, these are the convention to denote a set, right? And let's take an example. So A is a set which has, let's say, 5 elements, 1, 2, 3, 4, and 5. Now I am using, if you look at right here, I'm using curly braces. So for set, we use curly braces in mathematics. If I write something like A, 1, 2, 3, 4, and 5, this is not set. Why? Because in mathematics, we use this as a vector. So this is a vector in R5 space. Uh, Now, one of the fundamental doubt that the students face is order in set matters or not. So let's say I write A equal to 2, 1, 3, 4, and 5. So what did I do? I exchanged the position of these two elements of the set. So once I exchange the position between of 1 and 2 element, then my new set became 2, 1, 3, 4, 5. Now, if I ask you that this set and this set, are these two same or not? Let me write this question. Does this set change to? What should be the answer, guys? Anyone want to tell me? Anyone? So what did I do? I changed the position of these two elements, and I am asking you that this set and this set, are these two sets are same? Think. Come on, answer. Anyone? These two sets are same. The answer is yes. And the reason is that order does not matter. Always remember, order of elements in a set does not matter. Okay. Now, these items, the items that we have written in set A, items of set are known as elements. Okay, so what are the elements of set A? This is really basic, guys. I'm sure that many of you already know. Okay, so set of the elements of set A are 1, 2, 3, 4, and 5. I'm not using curly braces because that way it means set. So make sure that you write mathematically correct. Main concept and main questions that majority of entrance exam ask, especially IGIDR, is this questions from cardinality. So can anyone tell me what is cardinality of a set? Anyone? No answer, guys. Priyanka, Hardik,
I guess
Kulfisha.
the size is known as cardinality, something.
The number of elements present in the set.
Yeah, that is.
Okay, right. Anshu said the correct one. The number of elements of a set is known as the cardinality. Guys, please participate. I know this is your first session, and uh, this is gonna be fine. Okay, that's all I can say. So please participate if you can. Cardinality of a set is total number of elements in a set. So now you must be wondering that this is pretty easy because set A that we have taken, these are 5 elements. So cardinality of A would be 5, and we denote cardinality with 2 vertical lines. Two vertical lines. Okay. So this is the way we denote the cardinality. But the problem arises when you have complex set. So what do I mean when I say complex set? So let's take a complex set. Suppose V equal to a set 1, 2, 1, comma 2, 3, 4, 5, 6. This is a set. Now, if I ask what is the cardinality of this set, what do you say? Guys, if you are not going to be responsive, that would be a problem. So if I ask a question, try to take 30 seconds and answer. I asked what is the cardinality of this set. Okay, so okay, fine. So when it comes to set, I try to think of a box, and this is my approach, and that I have been doing for a very long time. And I believe this will help you to solve any kind of cardinality problem. So you make a box, and I'll give you a shortcut trick too that will make this problem really fast. So you take a box, and this is a box that represents set P, and all the elements that you are looking at. So elements are 1, 2, this element, and this element, and this element. So all these elements are in a section inside this box. So 1, 2, 6, element 1, comma 2, element 3, 4, and 5. So if you open this box, what do you see? What do you see? Think you will see all these 5 elements that I have written here, all these elements. So what should be the cardinality of this? This cardinality, how many sections did you make? 1, 2, 3, 4, and 5, right? So you made 5 sections. That means cardinality of B is 5. Now, what happens when you have this question, I mean, in a very complex manner, and you just want to know the answer? So the trick is, this is a shortcut. Where should I write this? Here. The shortcut is that you count total number of commas in outer braces. So what is your outer braces? This is your outer braces. Okay, look at carefully. This is your outer braces, and you count total number of commas. Total number of commas: 1, 2, 3, and 4. So shortcut is total number of commas in outer braces plus 1. Okay, that is your answer. So total number of commas in this one is 4, and you have to add one more. So that way you will get 5, and you have got 5 from this box method. But I mean, box method is really helpful. It gives you a better picture of set. But what happens, I mean, when you don't have time, so you want to move forward with a shortcut approach. The shortcut approach is I think really helpful to get your answer. Now the point is that what happens when we introduce more complex sets? So let's start with empty set. Can anyone tell me what is empty set? Okay, fine. A set which has no elements. Okay, a set which has no elements. This is called empty set, and the symbol of empty set is something like this. It was given by Andre Bell in 1940. Yeah, in 1940. Andre Bell was a famous mathematician in 1940 to 1920 to 1960, I guess. Yeah, Andre Bell was really good, well known for this symbol as well. Now, this symbol has the same meaning as this symbol because we represent set with curly braces and we are not writing anything inside it. So if you, like I just said in the box method, if you look at a box which represents empty set, there should be no section inside of it. You got it? So if you open this box, you will get nothing. There would be no section inside of this box. So if I ask that what is the cardinality of this, then you should say 0. Why? Because there's nothing here. Okay, there's nothing here. And also, if you can count any commas, can you do that? There is no commas, there's nothing. So that method works only when you have number of commas. So that's how you add +1. Here you can't do that because it's an empty set and it has no elements. So the cardinality of empty set will be 0. But what happens when I write something like this? What would be the cardinality of this? Take 30 seconds.
Sir, 1.
Yeah. All right. Who said it?
Jharna.
Yeah, that's very good. Very nice. Brilliant. So the answer is 1, right? Why? Because you look at the box method or you look at whatever approach you want. So there would be a section inside of this box, just one section, and this empty set will be taking the whole box, right? So from box method, you can get 1. Similarly, number of commas you count, it's 0, 0. Now here, number of commas, that shortcut method work. Why? Why? Because you have an element right here. When you don't have any element, that method fails. That method only works when you have element inside of a set. So it has number of commas are 0 and you add +1, so it will be 1. Very good. Now I'm giving you some problem and do it as fast as you can because I'll have to move on to next topic. So find cardinality. Oh God, this pen. Ignore my handwriting. I'm sure you all have understood this is cardinality. The set is 1, 3, 2, 3, 5, comma 5. Let me know if there is you can't. I mean, this is if this is not visible. Yeah, I guess this would be fine. Calculate the cardinality of all these 3. Guys, answer. Anyone? Charna? Midam? Anshu?
Sir, 4.
No, no. Tell me the first one.
5,
So first
5.
5,
What is the second one?
4,
second 3.
No, no, no.
I guess.
Okay,
I guess
one answer
5.
is 3. Someone said 4. Okay. Let me. Someone said 5 also. What's the answer of second problem?
4, I guess.
Okay, 4 is correct. Why? Same method. You count the number of commas in outer braces. So first comma here, second here, third here. You add +1. Answer is 4. What should be the third one?
5.
5.
5. So yeah, 5, 4, and 5. That is the answer. Brilliant, guys. Let's move on to the next part. That is a specification of set. This is not important right now, but I guess, I mean, not from exam point of view, but I'm telling you because if you guys will get into economics school, they start from this particular point. So there are 3 methods. One is list, enumeration. So like I used the earlier method 1, 2, 3, 4, 5. You actually list out all the elements of set. Okay, so in this method, you specify a set by listing out all the elements of the set. I'll repeat, you actually specify in this method by listing out all the elements of the set. That's how you get this particular notation or the specification of the set. So this works only when you have finite set that number of elements are very low and you can list them out. Otherwise, it doesn't work. Second method is set builder notation or set builder method. Make sure you guys write down everything. Okay, this is why I'm telling you this, because one reason to think about this that you will be making effort, you will make efforts to understand things and as well as write, so that way you learn more. And I would never recommend you guys to watch YouTube videos. After this, you can watch if you have attended the session. But if you are just relying on YouTube videos, that's not very good. So attend the session. That way, you would be able to learn more. Now, let's talk about set builder method. In set builder method, we use a predicate. Predicate is basically a statement to specify the property of the elements of a set. So let's take an example. Let's say if I tell you that I want a set n which has element x such that all x belongs to integer number, right? So what did I do? I guys, please mute yourself. Who is talking? Please do not talk in the middle of this, okay? Yeah, so I was saying that I specified a property. This is called your predicate. This line means such that. This line means such that I'm using the property to specify that all the elements belongs to integer number. So this is not a finite set, right? This is not a finite set. This is infinite set because the list of integers are infinite. So I have specified the property, and that way you know that what is your set. So where do we use this? We use in function, we use in real analysis, we use in theorems and proofs everywhere. So this particular notation is really important. You can think of something else. For example, let's say a list of, you want to specify rational numbers. So what are rational numbers? Rational numbers are in the form of m by n such that m comma n both belongs to integers, and okay, n cannot be 0. So I specified a set. This is a set of rational numbers. Now there is third method also, and this method is actually used by professionals. This method is not, students or any like during the teaching method it would ever come, but researchers actually use this method. We call it recursive method. In recursive method, you have 3 parts. In first part, what do? You denote a set with any capital letter of English alphabet. So let's say I have a set E, and I say I specify the first element. So write first element. So let's say I have first element which belongs to E. So I specified here. This is the example part. This is the algorithm part. Yeah, this is the algorithm part. What do you do next? Write the property to generate other elements. So how do you do that? You say that X belongs to E, you take a variable such that you don't write such that in this one, you write and X plus 2 belongs to E. So this means that X belongs to E and X plus 2 also belongs to E. So did I do, yeah, that's right. One way to, okay, you guys know statement, can I use it here? Anyone logic in a statement? If not, then I mean, I can move on. Okay, fine. So this is your example part, the ever one. So after this, you come here, and the algorithm that I have specified is write the property of write the property to generate other elements. And the last part is write restrictions. So restriction, what does it do? It actually helps you that to specify that your set is just this, and there are no other elements that actually belongs to this set. So no any elements beside the ever in the set. So we talked about three methods. Let's go again. First method is list or enumeration. You list out all the elements of the set, and this is only works for when you have finite number of elements in the set. Second method is set builder notation. This is we are going to use them frequently, and you will also use them while in your in your curriculum. So what do? We use a predicate statement to specify the property of elements of a set, and we write them like this. So I have talked about a set of rational numbers in which I have specified that m by n can m by n can generate all rational numbers if m comma n belongs to integers and n is not equal to 0. Similarly, third method is recursive method. In recursive method, first we actually find a symbol to denote a set, and that starts with the first element, and we write the first element, and then we write the property to generate other elements, and then we write restrictions. So you can have multiple restrictions as well. You do not have to worry about if you think that can we write just one restriction. No, you can write multiple restriction statements. Okay, now let's talk about the important thing. This is really important, and this is called subset. Can anyone tell me what a subset is? If all the elements,
Every element of set A is also an element of set B.
yes, who answered this question?
Simran.
Very nice. If all the elements of a set A, this is your set, guys. Okay, let me. A is also in set B. Then A is a subset of B. And how do you denote this? Something like this. Okay. So if you have to prove that A is not a subset of B, you just need one element of set A which is not in set B, right? So you just need to show that one element of set A which is in set A but not in set B. That way you can say that A is not a subset of B. So let's take an example for both 1, 2, 3. This is your A, and B is 3, 1, 4, 5, 2. Here A is a subset of B, right? But what happens when you take 1, 2, 3, and 5, and your B is same, 3, 1, 4, 5, 2. Now, can you say A is a subset of B? No. Why? Because you have one element in set A which is not in set B. Right, that's what I said here. You need to show that one element of set A which is not in set B. That way you can show that A is not a subset of B. Right? So always remember this. This is really important. Let's move on to okay, note empty set is a subset of every set. Let's prove that. Get into the proof. So write phi is a subset of A. Right. That's what you have to prove. What did you? Because I said that empty set is a subset of every set. Now, what did I say when I told you that how can you disprove this thing? I mean, not a subset of any set. So you need to show that one element of this set is not in A, where A is my universal set. Now, can you say anything about this? I mean, if I assume that phi is not assume. I'm using a method of contradiction, guys. So please remember that. I assumed that phi is not a subset of A. I just assumed. So can you say anything about this statement? Can you make anything? I mean, anything say about this particular statement that phi is not a subset of A? So phi does not have any element, right? Phi does not have any element. So we cannot say anything about our assumption. So that implies, I mean, if you cannot say anything about a statement, that implies that the statement is not false. The statement above is not false. Which statement is not false? Phi is not a subset of A. That statement is false. Okay. Uh, yeah, that statement is false, right? So because you cannot say anything about this, so we use a method called law of excluded middle. How many of you know this? Law of excluded middle says that every statement is either true or false, right? So if this is false, then this must be true, right? So this way you prove this one. Any questions in this one? I proved that empty set is a subset of every set. Any question? No question. Okay, let's move on. Let's talk about Cartesian product. So what do you mean by Cartesian product? First of all, let A and B are two sets. The Cartesian product of A and B is A cross B, which is a set of ordered pairs where first element is from set A and second element is from set B. So how do we write this? A cross B, A comma B. I'm using set builder notation. A belongs to A and B belongs to B. If I write B cross A, do you think these two are same? Can anyone answer? A cross B and B cross A, are these two same? Anyone?
I guess they are.
Okay. Why do you think this is same?
Like maybe like when we said that order doesn't matter, so by any means when we like multiply, we have the same number of elements in the set. So
Think again. Who is speaking? I can't see the
Miram.
screen. Miriam. Okay, Miriam. So think again what you said. Okay. You said that order does not matter in a set, right? Right. So your element earlier was just X. I mean, just one element you were picking. Now your element in this Cartesian product is this. Look at right here, A comma B. This is coming in ordered pair. I have written a definition here. You look at right here, set of ordered pairs where first element of set is from set A and second element is from set B. So if you look at right here, this comes in an ordered pair. Now, if you write
Will be
3,
equal
if you write 3 comma 2 and you write 2 comma 3, are these two same or not?
No, they are not.
Right. You got my point?
Yeah, I get it.
All of you understood it. So what he said everything right, but he missed one thing, this ordered pair part.
if A equals to B, then A cross B and B cross A are equal.
Right. So here, this is not same. Let me delete this one. This is very good insight. What is said, A cross A are equal to A cross A. I mean, this is not a big deal. You have same set, so ordered pair will always belong to the same. I mean, the pairs will always be same. So this is just like having a reflexive Cartesian product. Okay. Moving on, where do we use it? Let's take some of the examples as well. I mean, we use in real analysis. Again, this is really good for real analysis. So for example, you say, yeah. So, I mean, this is y-axis, this is x-axis, and you are in xy plane in first, in first quadrant. Then how do you denote this in Cartesian product? we denote this x comma y such that x belongs to R plus, y belongs to R plus, right? So this is one way to use it. Moving on, we can talk about, yeah, we should talk about power set. You guys are making notes?
Sir.
Yeah.
So what is R there?
Real number, but just the
Okay.
positive part and not included 0. I haven't included origin as well. Do you guys know this symbol? R
Okay.
plus, R plus plus, and R?
No.
Only positive real numbers. Positive and 0 real numbers. All real numbers. It is clear?
Yes, sir.
Yeah. Okay. Cool. You guys are making notes. And that's what I asked now. Huh? Are you guys making notes? Noting all this down in a notebook?
Yes, sir.
Yes.
Good. Good. So power set. Let's talk about that. The set of all subset of a set A is called power set. So we denote with power set as P and the set name and the set of all subsets. So I just said that empty set is a subset of every set, and whatever the subset except this one you will get, that would be the power set. So let's take example that 1, 2, and 3. So how many subsets do you think this set would have? First, tell me this total number
7.
of subsets of a set A would be 2 to the power cardinality of A. What is the cardinality of A? This is formula, guys.
2 cube.
Who said 2?
3.
It's 3. Um, please, don't you remember the shortcut method that I said? Count total number of commas. Or here it's easy. I mean, you can count total number of elements is 3. So it's 8. Okay, I can prove that how this formula comes, but I think I don't have that much time. If anyone is really interested, this is your homework. That prove total number of um, yeah, subset of a set, 2 to the power cardinality of a set, where A is a set. Just prove this one, okay? If you have time, yeah. So you can write all the subsets there. So 1 would be a subset, 2 would be a subset, 3 would be a subset. Similarly, you take pairs of 2, so 1 comma 2, 2 comma 3, and yeah, 1 comma 2, 2 comma 3, and 1 comma 3. So 1, 2, 3, 4, 5, 6, 7, and 8 is last one. Right. So we have done power set. What else? in the definition of estimate. Okay, this one is your homework. Just give me 1 second. Yeah, let's do some of the questions related to power set, and then this is also your homework, guys, because I have to take a lot of topics, true or false. Now, just make sure that you guys do your homework seriously. You just have to tell that whether this is the statement that I have written is true or false. Okay. Yeah. Mhm. One comma. Note down this homework. Is it done? Can I move on?
Yes, sir.
Okay. Yeah, so basic operations. Basic set operations are A union B. This means that I'm sure you guys can understand set builder notation. So I'm saying that all X such that X belongs to A or X belongs to B, A intersection B, all X belongs to A and X belongs to B. And the third one is A minus B. So all X such that X belongs to A and X does not belongs to B. That's it. Let's take an example and do it quickly. So I have a question that I'm so sorry. Yeah, I have a question that A is equal to 1, 2, 3, 4, and 5, B equal to 2, 4, 6, 8, and 10. You need to tell me A union B, A intersection B, A minus B, and B minus A. I'm sure this is pretty easy. Do it at your homework, this one too. And you guys can discuss in the WhatsApp group. I am not going to check this one, but I will ask you, any one of you, to prove the question that I have given with the formula. So you need to make sure that you guys try at least to prove that total number of subset of a set is 2 to the power cardinality of a set. So always remember that. I'll ask that one in next session. Now, Okay, this is the complement of a set. This is pretty easy. You denote with AC, yeah, A bar, as you wish. And this means that, I mean, AC means that element set A such that X does not belongs to A. X does not belongs to A. That's all it does means. So you can see through the Venn diagram that you have, suppose a set A. So whatever outside of this A set, that would be the complement of this set. So these areas are complement. These areas are complement. Okay, complement of set A. In A. So this is easy. Let's talk about universal set. Okay, so quickly to the universal set. Universal set. Can anyone define universal set? Let's get into technicalities a little bit. What do you think universal set is? Anyone? Think of it as a
Sets of
learning
all
process.
objects.
Yes, Simran, right?
Yes.
Yeah, go ahead,
Sets of
Simran.
all
Sets of all
objects,
objects.
like real
Okay.
numbers.
Okay. Yeah, this is what we all have studied. Anyone else?
Whose cardinality is not defined.
No. That's totally
Okay.
incorrect.
I get it.
No, what Simran said, that's the definition we all studied in high school and I think in college as well. But that's not the father of logic defined universal set. So I'll tell you what he said. His name was Gottlieb Frege, and he said the set of all possible things under, this is really important, under the type of consideration. Anyone knows Gottlieb Frege and Bertrand Russell story? Anyone, any mathematics enthusiast? No one? So after this session, I think you all should read about the Bertrand Russell and Gottlieb Frege story. So what do I mean when I said the set of all possible things under the type of consideration? So let me give you an example. Set of all vowels. This is a set. Now, the usual implication when I say vowels, you guys think of English alphabet. Or did you guys think Korean language? How many vowels in Korean language does anybody know? I think it's 44, I guess. 29 and 20, no, 21 and 19. It's 40, I guess. So total number of total number of alphabets in Korean language is 40. And total number of vowels are, I guess, 19. Anyways, what is the usual implication of set of vowels that I said? You think of English alphabet. So did you guys, I mean, now you understood why I wrote under the type of consideration. Guys, understood it? Okay, no response.
I get it. It's clear.
Anyone? Anshu, Simran, Gulfisha, Manvi is here.
Yes, sir, clear.
Okay, so yeah, so it is because the type that you are considering to make that particular universal set, that is also really important. So if you think of Urdu language or Hindi language, then your vowels will change, right? So the usual implication actually in consideration while you write universal set. So these I mean that's where technicality comes. So I won't take too much time in this one. This is not, I mean, really important. Uh, let's go to the next one. Next one is index set. Let's talk about this one and let's see what you guys think, because I think DSC has asked this question this on index set last year and before that also on index set. So let's say you have, I mean, n sets. So how do you work with that? I mean, not just one set or two sets. So you don't want to denote them, I mean, in a very vague way. So you take union of all these sets and you write I equal to 1 to 100. So the union this writing part thing is the union of all sets. Okay. And similarly, if you have an intersection, so you can denote similar way. And I'm assuming that n is equal to 100. Okay? So you don't have to worry about that. If you want to write just n, you can write n. The intersection of all sets. Now, this is a set of indices. So what exactly do I mean when I write this one? I mean that in set theory notation, I can say that X is such that X belongs to AI for some I belongs to integers, right? And similarly, X belongs to AI. This is a quantifier. Okay, I'll not use the quantifier. For all I belongs to I. Let's do a question and let's see what do you guys think about this. So for each natural number, n belongs to n, let an equal to n 1, 2, 3, 4, 5 to n. Have you guys noted this part? Guys,
Yes,
index
sir.
set noted. Okay, good. So this is the question that an equal to n minus of this, and let a equal to an, n belongs to natural number. Now, if I asked you what would be the union of an, n belongs to natural number, and what would be the intersection of an, n belongs to natural number? Do this problem and let me know the answer. Anyone answer?
The
Jharna?
union, I mean, the union is a set of whole
The union is a set of
numbers.
whole number. Okay, one answer is, let me write that. Who is answering this one?
Miram,
Miriam. Okay, set of whole numbers. And what is the intersection?
I guess 5 something. That's an empty set.
Okay, okay, okay. Anyone else, guys? Miriam, can you check union again? I'll give you a hint.
Yeah, for union, I mean, the capital N belongs to, like, from, it goes from 1. Is the set of all natural numbers. So
Yeah, so think again, think again. You're just missing one part.
okay.
Anyone else? Guys, please participate. This question is actually really good. I think DSC has asked a question based on this index set. Who else is here? Manvi, Anshu, Kulfisha, anyone? Charna, where is she? She's not answering. Okay, so let me write the answer because I've given you enough time, 3 minutes actually. So look at here. How exactly is my set defined? My set is an equal to n minus 1, 2, 3, okay, to n. I mean, something like that. This is going on. So I have said n belongs to natural numbers. Look at this, guys. Okay, this is really, really important. So your n starts with 1. So when you write a1, you write n minus 1. When you write a2, this is n minus 1, 2. So this is set of all natural numbers, but it is starting from 2. Why? Because you are subtracting one element. So your natural number, what is natural number? Natural number is 1, 2, 3, 4, and so on. But you are subtracting 1. So it the one, this particular element is not in this set, in A1. So it starts with 2, 3, 4, and so on. This starts with 3, 4, and so on. And once you take the union, you get actually n minus 1. Okay. I'm sure you all have understood it. You guys understood this one or not?
Yes, sir.
Yeah, you write down everything, you write down and you take union, you will get this one. And this is correct. I mean, this is pretty easy because there's no such thing. Actually, I should have mentioned that n is infinite. But I mean, see, this is the same thing that I said when I defined universal set, that usual implication thing. So I mean, n is always infinite because your n belongs to natural numbers. But look at right here. If you take intersection of this one and this one, you will get 3, 4, and so on. Similarly, next a3 will start with 4. So once you take intersection again, your set will start from 4. Similarly, it is going to infinite, so you can never reach to a single value which would be common in all these sets. So the answer is infinite. Okay, you guys want to take a break for 5 minutes? I think it's 12:15 and we have been starting for 1 hour. I'll stop sharing. take a break for 5 minutes and come back. Anyone would like to ask something in the middle of this break? You can go ahead. Nitigya is here. Hi, Nitigya. I really don't like people who aren't responsive. That's the first thing. You guys are just 12 students. I mean, Anshu? Anshu, are you here?
Yes, sir, I am.
How are you?
I am good, sir.
Good. You're from BHU, right?
Yes, sir, I am from the.
So, are you familiar with all the topics that I have covered today?
Yes, sir, except the index. I thought.
Your voice is breaking.
Yes, sir, I am familiar with all, but not with the index itself.
Okay. Okay. Fine. Can I start, guys?
Yeah, of course.
Yes, sir.
We can.
Okay. So, I'm going to talk about well ordering principle. And if you look at, I think the sample set of ICRDR, you will find some of the questions from well ordering principle in, I think, test B mathematics. So, but by the way, the answer is wrong. So don't worry about that. You can confirm with me or anyone. What is well ordering principle? It says that every non-empty set okay, every non-empty subsets of a non-empty set has okay, at one at least number, has a least element. So what did I say? I said every non-empty subsets of a non-empty set has a least element. So what do I mean? I mean that if you have a non-empty set and you want to take subset of that set, or you want to say that that set has a least element. So it is always true. I mean, this is one of the fundamental principles given by Frege, and you can check out MIT videos, or what I think Wolfram has a PDF on this one. So if you want to know about this in detail, you can get into that. I can give you some of the. I mean, one example I can give you is from basic mathematics, Euclid division algorithm. I'm sure many of you have heard of it. So Euclid division algorithm talks about what if you have a equal to bq plus r, right? So this R is always belongs to n between 0 to b. This is the fundamental theorem of division says. So this is the Euclid algorithm. I mean, if this satisfies, then R is always here. So if you are really enthusiastic about this one, you can take it as a homework and read more about this one. But the question is, has never been asked more into well-ordered principle, does except the fact that they ask questions from definition, and you should always remember that it has always a least element, whether it's a set or a subset, whether it's a non-empty set or a non-empty subset of a non-empty set. So always remember this.
Sir, repeat again.
Okay. So I said that if you have a non-empty, okay, let's take an example. So set of real numbers, is it empty or not non-empty? What do you think about this one? Set of real numbers, is it empty or non-empty set?
Non-empty.
Empty.
It is
Non-empty.
non-empty because you have many real numbers in this one, right?
Yes, sir.
So you take any subset of this real number set and you get 0, 1. Let's say I took this one. So can I say that it has a list element? Although I can't find it, but no matter what happens, I mean, no matter where I go approaching to 0 number, I can always find a list element, right? Because this is non-empty. This is non-empty subset of real numbers. So let's say I write 0, 0, 0, 0. I mean 0.0000000 and a very small number. Then somebody says that is this least number? No, I can always find another least number. But I know somewhere there exists a least element in this particular set. If I start listing down this particular interval, okay, or you can take any other example. I mean, okay, let's give you one more example. Let's say I have 2, -1, 0, 3, 4, and something. Does this set has a least element? Guys, does this set has a least element? Anyone? What do you think of this one? -1. Is this least or not? If you are not going to answer, then just ask me to move on. I'll move on.